Hey, and welcome back to another Make Math Make Sense Master Classic Math video. I'm your host, Mr. Shalongo, coming to you from beautiful South Phoenix, Arizona. I'm in my classroom here at Betty Fairfax High School. Shout out all my Betty Fairfax High School scholars. We're making it happen in and outside of the classroom. Also, a little special shout out to my viewers in the Philippines. Who knew? With the encouragement of my scholars, we're trying to make it to 400 subs by the end of October. So if you're not subbed, touch that sub button. And as always, after the video, make sure you tap the up thumb. Leave a comment with some feedback. Tell me what's your favorite way of solving quadratics. That's what we're doing today. That's why we're here. So let's get into it. So we've been working on solving quadratics, and we've got a couple different forms that we've been working through. We've got factored form and standard form, and we've got vertex form. And we've learned that in each of these different forms, there's a different strategy that we can use to solve. In factored form, we use the zero product property, and in standard form, we use the quadratic formula. We put a, b, and c. And then in vertex form, we solve by taking the square root. We would get rid of the k value, the a value, then the h, then the square, then the h value. And so we've got these different methods that we can use to solve a quadratic based on the form that it's in. The big things to remember in factored form and standard form, we've got to have an equal 0. So that'll be something that we look out for today. So let's go ahead and get into a couple problems. All right, Amani and Todd, we're trying to solve the equation x squared plus 6x plus 5 equals 8. And Amani says, I can factor the left-hand side to x plus 1 times x plus 5. Let's see if she's right. All right, let's look at what Todd's saying. So Todd's saying, I can solve by completing the square if I add 4 to both sides. Let's see what he gets if we added 4 to both sides. We'd have 6x plus 5 plus 4. And we add 4 to the right side. We would have, after we simplify, equals 12. X squared plus 6x, 4 and 5 would combine to 9. So now he's saying, here I have a perfect square, which is actually true, because what two numbers multiply to 9 but add to 6? The two numbers that multiply to 9 and add to 6 are 3 and 3. And we could rewrite x plus 3 times itself as a perfect square. That's exactly what a perfect square is. So we could absolutely complete the square if we added 4 to both sides. He's absolutely right. And then we would just solve by taking the square root. He doesn't necessarily mention that. I think it's assumed. We take the plus or minus there. We'd have x plus 3 equals plus or minus square root of 12. We subtract 3 to both sides, and we'd have negative 3 plus or minus the square root of 12, which would absolutely be the solution to this quadratic. Nice job, Todd. Amani, better luck next time. All right, Esma and Hunter, we're trying to solve the equation x squared plus 8x equals 2x minus 8. They both agree that they should subtract 2x and add 8 to both sides and rewrite the equation as x squared plus 6x plus 8, which would absolutely be what we get. If we were to subtract 2x from 8x, we would get 6x, and then if we were to add 8 to 0, we would get 8. So they absolutely are right on the first step. So we've got that equals 0 part, which is important if we want to solve using the quadratic formula or zero product property. Let's see what Esma decides to do. Esma says, I can complete the square if I add 1 to both sides. So she added 1 to the left side. We'd have x squared plus 6x plus 8 plus 1. That plus 8 plus 1 would give us a plus 9. And if we added 1 to the right side, we'd have equals 1. Then she says, after adding 1 to both sides, that we could factor. Okay, if we factor, we're looking for two numbers that add to 6 but multiply to 9. Those two numbers would be the same number. So she would, in fact, have created a perfect square here. And then she says she would solve using the square root, which we could totally do. Take the square root of both sides, boom, boom. X plus 3 equals plus or minus square root of 1, which is just 1, right? The square root of 1 is 1. And then we would subtract 3 to both sides, and we would have x equals negative 3 plus or minus 1. We'd have x equals negative 2 and negative 4. So we can absolutely solve using Esma's method. Nice job, Esma. Now let's look at Hunter's method for solving. I'll factor the left-hand side to x plus 2 times x plus 4. Let's see if that comes back to what it needs to. We get x squared here. We get 4x, 2x right there, and 2 times 4 would be 8. 4 and 2 combined to 6, so we would absolutely get back to where we started. So he's right about factoring that. And then he says that we would use the zero product property to solve. And we can only use the zero product property if we have a 0 on one side, which we absolutely do. So we're just looking here, what number plus 2 would give us a 0? Negative 2 would create a 0 in the first factor. And then in the second factor, what number plus 4 would create the 0? Negative 4 would create the 0. We can absolutely solve. We get the same exact solutions if we solve using that method. So both of these scholars are absolutely right in the methods that they chose to use. Nice job.